Good evening all. Welcome to Kerala NEET Academy NPL Season 2. நான் வந்து உங்களுடைய ISD sir, and today we'll be discussing some of the important topics in physical chemistry and also in coordination compounds. So I know everyone will be busy preparing for your NEET examination, and this session will be entirely helpful for you. We'll be discussing the most important questions that we can expect for NEET examination. So you know that in physical chemistry, most of the questions will be based on numericals. So that we should be able to solve the numerical in a given time. That means maximum we need to use the shortcuts. So such things like whenever we are having a question, we can go for the direct method and also we'll be having some shortcuts. So wherever we can apply the shortcut, that also will be discussed in this session. So we'll go to the session. Now we'll start with certain important questions. So you can see this question is from basic concepts of chemistry. Okay. So what mass of hydrochloric acid is needed to decompose 50 gram of limestone? So this question we can expect in two ways. Either it can be like direct, the one which I have given now, or it can be like 20% of limestone or 10% of limestone. Okay. So if it is mentioned as like 50 gram of limestone means you can take that compound to be 100% pure. And now we have the equation. So that's come from the stoichiometric calculation. So here in this chapter we'll be going with the stoichiometry. So calcium carbonate, that means limestone means it's calcium carbonate, and you know the reaction between CaCO3 and HCl. Now listen here, CaCO3 calcium carbonate plus 2HCl. So you should know this reaction. Okay, giving CaCl2 plus CO2 plus plus H2O. So this is the balanced equation. And in this reaction, you know that 1 mole of calcium carbonate, in order to react, it requires 2 moles of HCl. It requires 2 moles of HCl. Hope I am audible to you. Okay, so if you have any issue, just raise some comments. Okay, so that I can see here. So 1 mole of calcium carbonate will be reacting with 2 moles of HCl. So here you know that 1 mole of calcium carbonate, its molar mass will be equal to 100 gram per mole. So 100 gram per mole calcium carbonate react pannadukku we have to require 2 into HCl vandu 36.5 gram. So this is the stoichiometry. 100 gram of calcium carbonate will require 2 into 36. Okay, it will be like 73 gram. And now for 1 gram, so for 100 gram it requires 2 into 36.5. So for 1 gram the requirement will be like we can say like 1 gram will require 2 into 36.5 gram divided by 100. And here in the question they are asking for 50 gram. So for 50 gram again the calculation will be 2 into 36.5 divided by 100 into 50. So you can cancel 50 and 2, and so the answer will be 36.5 gram. 36.5 gram. So this will be the direct calculation. So here we know that if I take like 50 gram of calcium carbonate, if you take 50 gram, okay, if I take 50 gram of limestone, that will be producing, or it requires 36.5 gram. 36.5 gram of HCl will be consumed. But if it is like 50% or 20%, then the amount will be like 30. If the purity is given, then it will be the calculated value into purity divided by 100. Okay, into purity divided by 100. And this was the question which was asked for like last NEET examination, okay, in 2023 and also in 2022. Most of the question was based on this stoichiometric calculation. So if purity is given, so if no purity is given means you can go with this direct calculation. And if purity is given, then you can take it as like the given answer, the calculated answer into purity divided by 100. And now listen here, if I take next case, now in this one you can also apply a crisscross method. Okay. Now you know that calcium carbonate, the question is regarding calcium carbonate and HCl. So first you write the stoichiometric values. So 100 and like 73, 2 into 36.5. So for 50 gram or whatever the weight given, okay, it will be, you can take it as X. So you cross multiply and find the value. So that will be the answer. So stoichiometry, we can expect a question from the stoichiometric section. Okay, so this will be the answer for this particular question. And also remember, there are certain equations that you have to by heart. For example, the one which I have given now, and you can take some other equations also. For example, like the reaction between or KClO3, decomposition of CaCO3, okay, calcium carbonate, CaCO3, that one the decompose on heating, it decomposes calcium oxide plus carbon dioxide. It decomposes to calcium oxide and carbon dioxide. Remember, calcium oxide was the solid and carbon dioxide will be the gas. So the question may be calculate the amount of residue obtained. So residue means you have to take the solid. Okay, so residue obtained means something which is present in the solid form. So the residue, the weight of residue means you have to calculate the weight of calcium oxide. And then you have a potassium chloride. If I take the case of KClO3, potassium chloride. Potassium chloride on heating it produces potassium chloride and 3 molecules of oxygen. Potassium chloride will be solid and oxygen will be gas. And remember the molar mass or the atomic mass of potassium will be 39. In order to calculate the molar mass of KClO3, the mass of potassium will be 39. And you know the mass of chlorine. Chlorine was the 35.5 and oxygen will be 16, the normal masses. Okay. Then you can take like 2SO2 plus O2 giving 2SO3. Then we have the equation like if you take the case of 2Mg plus O2 giving 2MgO. In magnesium oxide that will be in solid form. So the mass of residue. Okay. So these are the important reactions you have to remember in stoichiometric calculations. Okay. Now we'll move on to next question. Listen. For every one Cl17 isotope, there are 3 chlorine 35 isotopes in a sample of chlorine. What will be the average atomic mass of chlorine? So you know that the average atomic mass of chlorine, it's the direct answer 35.5, but we have to see how we are getting that 35.5. Okay. So here, actually this average atomic mass means it's a calculated value. And remember, there will be no chlorine atoms. There will be no chlorine atoms which is having a mass of 35.5. It's just a calculated value. For example, I'll give you one element. Let's take an element A. Now, let it have 2 stable isotopes. Let it be like 20 and 22. So, you have an element A with an atomic mass of 20 and with another atomic mass 22. And let it be present as like 75%. Let the percentage abundance of A, let it be 75, and that of B, let it be equal to 2, because total percentage should be 100. So 75%, now the calculation, the average atomic mass, you can calculate the average atomic mass as 20 into its abundance, 75%. So calculation, average atomic mass is equal to 20 into its percentage. Plus, next one is 22. So 22 into 25 divided by 100. If you have a third element, if you have one more like A with some other atomic mass, you can do the same. Okay, so it will be like the atomic mass of the first element into its percentage plus atomic mass of the second isotope into its percentage. If you have like a third one, then atomic mass of third one into its percentage whole divided by 100. So this will be the calculation. Now listen here. Now here it is mentioned like for every 1 chlorine 37, okay, for every 1 chlorine 37, there are 3 chlorine 35. So there are 2 isotopes, okay, chlorine 35 and chlorine 37. And for each 1 chlorine isotope, or for each chlorine 37, we are having 3 chlorine 30. That means they are present in the ratio 1:3. That means 37, chlorine 37 and 35, they are present in the ratio 1:3. 1:3 means it will be like 25:75. You know that 25:75, or else you can take it as 1:3. So I'll tell you. So chlorine 35 will be like if I take the case, it will be 75%. Okay, 75%, and 37 will be 25%. Or else you can take it as, like 3:1. Okay, 3:1. Any one you can take. So the calculation will be 35 into 75 plus 37 into 25, then divided by 100. See how to reduce the negative marks. How to reduce the negative marks means you have to be very careful. Okay, now try to reduce your careless mistakes. Okay, whenever you are getting a question, read it carefully because there will be some twist will be there in the question. So first identify or whenever you get a question, you read it carefully and identify the concept that you have to apply there. Anyhow, we'll be discussing the questions. Okay, now on solving this one, whatever be the value, you'll be getting the answer. And now or else you can also apply like 35 instead of 75 you can give it as 3. Okay, 35 into 3 board plus 37 into 1 divided by see, don't give 100 because we are taking 3 and 1, so it will be divided by 4 board. So that also will give you the same answer. So this will be the calculation part. But now I'll tell you, we'll go with a shortcut. Okay, we'll go with a shortcut. But remember, this shortcut can be applied. This shortcut can be applied only when you are having only 2 isotopes. Okay. Now you know that chlorine வந்து chlorine 35 இருக்கு and also chlorine 37. So இது வந்து 75% and this is 25%. 75% means it is actually 75 divided by 100. 75 divided by 100. So that means it will be 0.75. இல்லையா? 25% is 0.25. அது வந்து fractional abundance னு சொல்லும். So chlorine 35 க்கு fractional abundance வந்து 0.75, 37 க்கு fractional abundance வந்து 0.25. Okay va? Now listen here, the average atomic mass, single step you will get the answer. Average mass is equal to, see ee rendu isotopes you take the minimum value, the least value. Okay, that means we call the lowest, that means the lowest one. Okay, so அது வந்து 35 plus identify the difference. 35 37 க்கு வந்து difference வந்து 2. Okay, 30, so the difference will be 2 into the fractional abundance of the heavier isotope. So it will be the lower isotope plus the difference into the fractional abundance of the heavier. So fractional abundance of heavier isotope வந்து எவ்வளவு வரும்? 0.25 தானே. So into 0.25 you'll get the direct answer 35 plus 0.5 which is equal to 35.5 U. This will be the answer. So in a single step, no need to go for that big calculation. So this is because no one is bothered about the method, how you have done the numerical. The only thing is that from these 4 options, you have to identify the right answer. So this is how we can, now I'll give you one more question. Okay, I'll give another question. Now listen, you have like an isotope. Now let me take an element A. Okay, let me take an element A. Okay, now let the isotopes, let it be 30 and 33. 30 and 33. Now A30 வந்து let it be like 80%. And next one is 20%. So can you tell me what will be the answer? What will be the average atomic mass? What will be the average atomic mass? Can you try that? So A30 and A33. Now A30 with 80% and A33 will be like 25%. So can you find the answer for this one? Try it. Okay. So with the same method. So which is the smallest value? Smallest value வந்து okay, you can comment your answer. You can comment your answer there. So smallest value வந்து 30 plus இதுக்கு difference எவ்வளவு வந்து difference வந்து 2. Sorry, difference will be 3. Okay, the difference will be 3 will be their difference 3 into 20%. Heavier isotope வந்து 33. So 20% means 20% is 20 by 100, that's equal to 0.2 வந்து 3 into 0.2 0.6. Answer வந்து 30.6 will be the answer. Answer will be 30.6. Okay va? So this is how we are calculating the average. Okay, average atomic mass. Okay, it will be 30 point the difference into the fractional abundance of the heavier isotope. Is it clear? Okay, so this will be the best method. Okay, no need to go with, but you should know the method. That's it. Don't study only the shortcut. But if you have a third, now if you are having A like 35 also, then you cannot go with the indirect method. Okay, that means you have to go with the direct method itself. Okay, wow. And now I'll give you one more question. Okay, I'll give you, is it clear now? Is it clear one? Everyone? Okay. Bhairavi. Then Soundarya Murugan. Okay. Hope it is clear for you. Now let me go with the next question. See. Now carbon occurs like it will be like the average atomic mass. Okay, like 12.011. The average atomic mass, okay, now occurs as 12.011. What is the percentage abundance of C12 in nature as a mixture of C12 and C13? what will be like the average atomic mass? Okay, now listen here. Now listen. The question will be a little mistakes is there in that question. So you can take. We have two isotopes. Okay, C12 irukku, C13 irukku. C12 and C13. Idhukku average atomic mass evlo 12.011 ആണ്. 12.011. So they are asking what will be the percentage, okay, what will be the average atomic mass, or what will be the percentage abundance of like carbon 12. We have to calculate the percentage abundance, okay, percentage abundance of carbon 12. So let it be x, edukku x podikku, like x percentage. Then what will be the value of carbon 13? So carbon 12 on the x percentage irunda, 13 will be 100 minus x illaya, because total percentage evlo vandadno, total percentage 100. So what is the calculation? Average atomic mass evlo? Average atomic mass 12.011. So average atomic mass is equal to 12 into x plus 13 into 100 minus x divided by 100. 12 into x plus 13 into 100 minus x divided by 100. Solve pannano and you need to get the value of x. Like a lengthy calculation will be there. Now you can see the same shortcut you can apply here. How can you do? So you will apply the okay, everyone good, giving the good answers. Okay. Now listen here. In order to do this numerical, there also you can apply the shortcut. So you know that C12, C13 C12 and C13. So here now we know that C12 vandu the average atomic mass evlo varum? Average atomic mass vandu 12.011. The average atomic mass is 12.011. So what is the percentage abundance of carbon 12? Now listen here. We know that the average atomic mass, the calculation will be the smallest value. Smallest value evlo? Smallest value vandu 12. Smallest value 12. Plus adukku difference evlo vandu? Difference vandu 1 thane 1. Into fractional abundance of carbon 13. Fractional abundance of carbon 13 we don't know. Okay, appo adukku x board. So let it be x. And this answer is equal to 12.011. This answer is equal to 12.011. So x is equal to, x solve one, you will get 12.011 minus 12, that's equal to 0.011. 0.011. So carbon 13 ku fractional abundance evlo? Carbon 13 ku fractional abundance 0.011. So okay, 0.011. So what will be the percentage? Percent into 100 podiya podum. So it will be 1.1 percentage. Carbon 13 1.1 percentage vanda, what will be carbon 12? Total vanda 100 thane, so it will be 98.9 will be the answer. 98.9. So I know it's a very simple question. Okay, it's like directly if you do the calculation you'll get the answer. But the concern is that you are 12 or like 2 to 3 minutes we will be spending on that particular question, so that you will not be able to complete all the physical chemistry question in the required time. And for that one, we have to apply these kinds of shortcuts. Okay, so this is the first shortcut that we have discussed in this chapter in order to calculate the average atomic mass, right? Okay. Now we'll move on to the next question. The number of oxygen atoms present in 1 mole of oxalic acid dihydrate. So there are like two concepts we have to apply in this question. So someone was asking me now how to reduce the negative mark. See, if I tell you like 1 mole of sulfuric acid, H2SO4, appo formula theriyu. Appo formula theriyappo H2SO4 la you know that anga 2 hydrogen atom irukku, 1 sulfur atom and 4 oxygen atom. Appo formula therinja it is easy. But instead of giving the formula, they have given like oxalic acid dihydrate. So you should know the formula. Appo oxalic acid dihydrate ku therinjirikano, then urea, then benzene ku ungalku theriyum. So urea vandu NH2CO NH2. So let me take this one for first question. See, oxalic acid dihydrate. Oxalic acid vandu you are studying that formula from like aldehyde ketones and carboxylic acid chapter. Okay va? So H2C2O4 on oxalic acid. Dihydrate means dot 2H2. So this is the formula for oxalic acid dihydrate. Now inga paru evlo oxygen atom, if you have one molecule, if you take one molecule of oxalic acid dihydrate, how many oxygen atoms are there? Inga paru na 4 oxygen atom in H2C2O4 anga 4 irukku, and H2 one oxygen atom, H2 will be having 1, appo evlo oxygen atom 2H2 இருக்கு. அப்ப total வந்து 2 oxygen atom will be there in water. So total oxygen வந்து 4 plus 2 தானே, that's equal to 6. That's equal to 6. So we are having 6 oxygen atoms in one molecule. Okay, if I take one single H2C2O4 dot 2H2O, அப்படி ஒரு single oxalic acid dihydrate ல எவ்வளவு oxygen atom இருக்கும்? 6 oxygen atom. அப்ப 2 oxalic acid dihydrate இருந்தா 12 oxygen atom. 10 oxalic dihydrate means 60. 100 600. 1 mole 6 mole. 10 mole 60 mole. So if you know the total number of oxalic acid dihydrate in 1 mole, then you will get the answer. So let me give you the number of molecules. Okay, now here we'll apply the number of molecules. So before going to remaining topic, let me tell you how to calculate the number of moles, number of molecules. See, we used the term like mole, okay, mole, and also you know about molecule, yeah, mole and molecule. Both are not same, only similarity in their spelling mattum da similarity irukku. Molecule vandu like it's like we can say that one molecule of carbon dioxide vanda oru carbon dioxide. Ipo inda marker illaya, so I can say that one molecule of marker, that means single marker. Now if I have one more with me, I can tell two molecule. So molecule means that represents a single species. Okay, ana vanda carbon ipo idu C, adu vanda carbon atom. C is called carbon atom. Okay, ipo C2 vanda, if it is C2 you can call it as carbon C2 molecule nu sollu. So at least you should have two atoms. Okay, now if I take carbon dioxide, adu vanda molecule. Okay va, so mole means, and mole represents, it's a number. Mole vandu oru number, like we used to say oru like one dozen, le oru dozen vandu 12. Then one pair, that represents 2. And such a large number, we have a large number which is called 1 mole, and 1 mole represents 6.022 into 10 raised to 23. 6.022 into 10 raised to 23. Okay va, so that represents 1 mole. And now we'll see how they are converted. Okay, so mole means it's just a number, and molecule means it's like a particle. Okay, now for 1 mole, okay, now if I have mole can be converted, okay, number of moles, n. It can be converted to weight in grams. You can convert that into weight in grams. It can be converted into number of molecules. You can convert that into number of molecules. It can be converted to volume in liters of gas at STP, at standard temperature and pressure. Now listen here, if you want to convert that into weight in grams, you have to multiply with the capital M. Number of moles into capital M. Number of moles into capital M will give you the answer in grams. The weight in grams will be obtained. And if you want to convert weight in grams to number of moles, okay, weight in gram to number of moles, you have to divide by capital M. Divided by capital M. Number of molecules number of moles into Avogadro number. Number of molecules is equal to number of moles into Avogadro number. Now number of molecules and number of moles convert pannadukku divided by Avogadro number. Clear? Now next calculation, see, now you have to go with moles in a volume in liters. Okay, that is applicable only for gases. This is applicable only for gases. Multiply with 22.4. So that 1 mole is equal to 1 into 22.4 liters at STP. 5 moles, 5 into 22.4. Okay, and divided by 22.4. This chart will be enough. Okay, now in order to calculate the different values. So moles in a, you have to convert to weight in gram. You can convert to number of molecule. You can convert into volume in liters of gas at STP. Is it clear? Okay. Is it clear? So future doctor, very good. Okay. Ishani, Vinod. So you should know these calculations. Okay. Now we'll listen here in the question. Now in this question, the number of oxygen atom present in 1 mole of oxalic acid. So let me calculate. So you know that number of molecules. Okay, number of molecules is equal to number of molecules. See the formula, that is equal to number of moles into Avogadro number. Number of molecule is equal to number of moles into Avogadro number. Then this is equal to, so number of moles வந்து எவ்வளோ 1 mole இருக்கு. So 1 into 6.022 into 10 raised to 23. So that much molecules are there. So we are having 6.022 into 10 raised to 20, and you know that each molecule will be having how many oxygen atom? 6 oxygen atoms will be there. Yeah? Each molecule will be having 6 oxygen atoms. So what is total number of atoms? Total number of oxygen atoms. Total number of oxygen atoms. Total number of oxygen atoms. That is equal to like 6 into number of molecules. 6.022 into 10 power 23 vandu. So that is equal to 6 into 6, approximately 36 into 10 raised to 23. Okay, 36 into 10 raised to 23. That will be the answer. So remember, like this will be the calculation that we are doing for calculating number of molecules. So konja formulas you have to know that. Okay, so I'll give you some of the formulas. See, number of molecule, okay, number of moles that is equal to given mass divided by molar mass. Number of moles, okay, number of molecules that will be equal to n into Na, or that is equal to given mass divided by molar mass into Na. Given mass by molar mass, both will be representing the number of molecules. And now you can like volume, okay, volume in liters of gas at STP, that is equal to number of moles into 22.4. Molar mass is equal to molar mass of a gas, that is equal to density at STP into 22.4. Density of gas at STP into 22.4. Okay, are you getting? Soundarya, how to find your question is not complete. Okay, Maheshwari, is it clear? Vinod, Ismail, Ishani. So take down these formulas, okay, or just take a screenshot, that's enough. So molar mass is equal to density at STP into 22.4. And now you have a concept which is called atomicity. Atomicity means total number of atoms. Okay, Ishani, Soundarya will go to that one. Total number of atoms is equal to, atomicity means total atoms present in a molecule. Suppose if I take H2O means how many atoms are there? Anga 3 atoms da irukku. Appo atomicity vandu 3. NH3 பாரு, NH3 atomicity எவ்வளவு வரும்? ஒரு நைட்ரஜன் 3 ஹைட்ரஜன், atomicity வந்து 4. Atomicity is equal to 4. Then if I take H2SO4, okay, H2SO4 atomicity like 2 hydrogen, 1 sulfur, 4 oxygen. So that will be total, that will be giving you 7. So number of atoms, okay, now Soundarya listen here, number of atoms that will be equal to number of molecule calculate பண்ணது உங்களுக்கு தெரியும் இல்ல. Now I have discussed number of molecules into atomicity. Number of atoms is equal to number of molecules into atomicity. Okay va, appo atomicity வந்து total number of atoms. Okay, total number of atoms present in a molecule, that's called atomicity. Appo total number of atoms therinja. Appo previous question, okay, now in previous question you know that oxalic acid dihydrate means, now see here, now H2, okay, H2C2O4 dot 2H2. அப்போ ஒரு H2O ல 3 atoms, அப்போ 2H2 ல how many atoms? இங்க 6 atoms இருக்கு. H2C2O4 means total 8 atoms. அப்போ total atomicity வந்து எவ்வளோ? 14. Number of electrons ஆனா you calculate total number of electrons. H2C, அப்போ H2 ல எவ்வளோ electrons ன்றது calculate பண்ணு. C2 ல எவ்வளோ electron, O4 ல உள்ள total electron and H2O ல உள்ள total electron. So normally number of molecule or number of species will be equal to number of molecules into the given parameter. So that means whenever you are having these kinds of questions, okay, you have to multiply with atomicity. Number of electrons ana you calculate how many electron is there in one molecule. Okay, that means total number of molecules into total number of electron will give you that answer. Okay, anyhow we'll move on to the next one. The density of gas, okay, we know, we'll go to that one, okay. The density of gas is 1.78 gram per liter at STP, the weight of 1 mole of gas. See, the weight of 1 mole of a gas, that's called molar mass. Molar mass is equal to mass of, അല്ലെങ്കിൽ weight of 1 mole of gas, weight of 1 mole of a substance ன்னு சொல்லும். Gas ആണ് gas, liquid ആണ് liquid, okay, based on 1 mole of a substance. Or it is weight of Avogadro number, weight of 6.022 into 10 raised to 23 molecules, അല്ലെങ്കിൽ substances. Or that is equal to the mass of 22.4, okay, mass of 22.4 liter of gas at STP. Or molar mass is equal to density at STP into 22.4. Density at STP into 22.4. So you have a gas having density 1.78. Density will be 1.78. So what will be the molar mass? Okay, molar mass is equal to, so the mass of 1 mole of a substance is called molar mass. So capital M is equal to density at STP into 22.4. That's equal to, that you will be getting an answer like density 1.78 into 22.4. 1.78 into 22.4. So we know that 22.4 into 2 will be 44.8. Your answer will be, like, if you are multiplying with 2, it will be 44.8. So your answer will be less than 44.8. So the answer will be like approximately, it will be, the first option will be the answer. Okay, right answer will be 39.9 gram. So the weight of 1 mole of a gas is called molar mass. Okay, this is called molar mass. So actually we are calculating the molecular mass or molar mass of the substance. Okay. Is it clear, everyone? Ready. Okay. Now listen. Total number of atoms present in 34 gram of ammonia. Okay. Now Soundarya Murugan, now the type of question that you have asked. Total number of atoms present in 34 gram of ammonia. So we know that number of atoms, okay, what? So number of atoms, which is the formula we are applying, number of atoms is equal to number of molecules into atomicity தானே, into atomicity. So ammonia வந்து atomicity எவ்வளோ? ammonial atomicity வந்து 4. ஒரு nitrogen 3 nitrogen இருக்கும். So you are having atomicity 4. See, these are the types of questions that you can expect for the NEET examination. Okay, everything will be based on NCERT. And now listen here, number of molecule calculate பண்ண வேணும். Number of molecule is equal to number of molecules. We are having two formula. So I will apply given mass by molar mass into Avogadro number. Given mass by molar mass divided by, or given mass by molar mass into Avogadro number. See, now listen here, given mass வந்து 34. Given mass 34 gram. Ammonia molar mass வந்து 17 into Avogadro number 6.022 into 10 raised to 23. 34 by 17 வந்து 2 into 6.022 into இவ்வளோ molecules இருக்கும். So this is the total number of, okay, ammonia molecule, this much ammonia molecules are present, இனி என்ன பண்ணணும், இந்த வேல்யூனை multiply with atomicity to calculate the total number of atoms. Atomicity 4 தானே, so answer எப்படி வரும், 2 into 6.022 into 10 raised to 23 into 4. So you know that 6 into 4 வந்து 24 into 2 48. அப்ப ஆன்சர் வந்து 48 into 10 raised to 23 வரும். 48 into 10 raised to 23. Calculation part you can do it. Okay, so this is the theory that we have to apply here. Okay, the theoretical part. And see, the based on color. Okay, now we know, now color based questions we can expect from like structure of atom. So the reason will be excitation of electrons. Okay, and if you are getting question from d block element ആണെങ്കിൽ normally d1 to d9 you write the electronic configuration, and if you are having any configuration from d1 to d9 it will be colored. And if your configuration is d0 and d10 configuration ആണെങ്കിൽ it will be colorless. The reason for color is excitation of electrons. Okay, excite, and that and now if you have, there is an exception also. Okay, appo in the part ipam manganese KMnO4 edukku, If you take KMNO4, okay, I'll give one exception also because sometime D0 will also be colored. இப்போ வந்து KMNO4ல KMNO4ന്റെ കളർ உங்களுக்கு தெரியும். KMNO4ல that is having a purple color. ഇതിൽ മാംഗനീസിന്റെ കോൺഫിഗറേഷൻ D0 ആണ്. Even though it is D0 because we are expecting D0 and D10 க்கு வந்து colorless தான் expected. So here D0 configuration of KMNO4 is also colored. The reason is that it is called charge transfer mechanism. Okay, charge transfer mechanism nu sollu. Charge transfer mechanism. Okay va. Anyhow, we'll move on to the next question. What will be the mass of 100 atoms of hydrogen? What is the mass of 100 atom? இப்போ ஒரு ஹைட்ரஜனுக்கு ஆட்டத்துக்கு mass x. If you have one hydrogen, if the mass is x gram, then what will be the mass of 100 that atoms? 100 atoms will be having a mass that will be equal to 100x. அப்போ ஒரு ஆட்டத்துக்கு mass தெரியணும். So mass of one atom, take the formula, mass of one atom that is equal to capital M divided by Na. Capital M divided by Na, where M is the atomic mass. Mass of one molecule, that is also, 1 minute, just wait, okay. Okay, so mass of one atom, okay, mass of one atom will be equal to capital M divided by Avogadro number, capital M divided by Avogadro number. Mass of one molecule is also capital M divided, M will be the molar mass. So they are asking what will be the mass of 100 oxygen atoms. Okay, what will be the mass of 100 oxygen atoms or 100 hydrogen atoms? So mass of one hydrogen atom. What will be the mass of one hydrogen atom? That will be equal to 1 by capital M divided by Na dane. So mass of one hydrogen atom, 1 molar mass, divided by 6.022 into 10 raised to 23. This is the mass of one hydrogen atom. Then what will be the mass of 100 hydrogen atom? 100 hydrogen atom's mass வந்து இந்த value into 100 தானே. So 100 into 1 by 6.022 into 10 raised to 23 வந்துடும். So you do one thing, இது separate ஆயிடு பண்ணு. 1 by 10 raised to 23 is 10 raised to minus 23. 100 divided by 6. 100 divided by 6 வந்து ஒரு your answer will be like 16. Okay, 16 point something. So 16 ആണ് 16.6 போடு. So 16.6 into 10 raised to minus 23 gram. Or it will be equal to 1.6, okay, 1.67 into 10 raised to minus 24, okay, sorry, 22, okay, 22 gram. So this will be the answer, 1.66 into 10 raised to minus 22. So number of atoms will be equal to like 1.67 into 10 raised to, so okay, minus the mass of 100 atoms will be 10 raised to minus 22, okay, 22 will be the answer. And listen, ee decimal place move pannadukku, whenever you are moving the decimal place to the right side, okay, whenever you are moving the decimal place to the right side, 10 க்கு power decrease பண்ணனும். If you are moving 2 places to the right, decimal place 2 places to the right ആണെങ്കിൽ 10 ന്റെ power minus 2 will be the answer. If you are moving decimal place to the left side like decimal place move ചെയ്താൽ the power of 10 should be increased. Left like if you are moving 3 point, that means 3 decimal points to the left side means 10 raised to value plus 3. I'll give you one example, listen. We'll take one example. Hope this question is clear for you. 0.000189 into 10 raised to minus 5. Now here this is your decimal point. Now you are moving decimal point, see 1.89 akam, which means you are moving 1 2 3 4 places to the right side. So your answer will be 1.89 into right side and you have to decrease it. Decrease means minus 4 vandu. 4 places to the right, so 10 raised to minus 9 will be the answer. So whenever you are moving to the right side, you have to subtract that much number of places. Left side, like if you are moving, you have to add that much number of places. Okay, is it clear? Shaul Amid, we'll see whether we are having any tricks. Okay, let me go take that question. A compound contains 2 elements x and y in the ratio 50% each. Atomic mass of x is 20 and y is 40. What can be their simplest formula? You know that this simplest formula, we call this simplest formula as, that means it is called the empirical formula. That is called the empirical formula. Okay, Ishani, okay. Okay, good. Maheshwari, good. Now you are having two elements. അപ്പോൾ x and y ആണ് രണ്ട് elements. So you can write it as element வந்து x, y. Okay, no need of that table or column. Okay, because we are not doing that plus 2 level. So x and y ல 50% each ആണ്. Whatever be the percentage, അതിനെ ഗ്രാമിലേക്ക് കൺവേർട്ട് பண்ணு. So mass, இதுக்கு mass வந்து 50 gram. X வந்து 50 gram, y வந்து 50 gram. 80-20 ആണ് 80 gram 20 gram. 90-10 ആണ് 90 gram 10 gram. Next case you calculate the number of moles. Okay, next case you calculate their number of moles. Number of moles and the given mass by molar mass thane. Number of moles is equal to given mass divided by molar mass. So given mass 50, x ku molar mass evlo, x ku molar mass 20. So it will be 50 divided by 20. Do it fast. 50 divided by 20 means 100 divided by 40. Okay, 100 divided by 40 10.5. So that will be equal to 2.5. Next number of moles 50 divided by evlo varum 50 divided by 40. 50 divided by 40. 50 divided by, wait 1 minute. The calculation is correct now. 50 divided by 20 will be 2.5. Yes. 50 by 40, that will be equal to 1.25. 1.25. So you are getting like 2.5 moles of x and 1.25 moles of y. Now you have to divide with the smallest number. Okay, this number of moles you divide by the small. Now this 2.5 and 1.25 smallest number is 1.25. 1.25 on you have divide with both the number of moles. 2.5 divided by 1.25, that's equal to 2. Next 1.25 divided by 1.25, that's equal to 1. Appo x evlo atoms 2 atoms, y evlo atom 1 atom. Simplest formula eppadi varu x2y. And if it is you are getting 2.5, suppose 2.5 vanda you multiply with 2 and make it 5. Okay, so if it is, okay, for this one the answer is x2y. But if your calculation goes like 2.5 and 1 means next step like you multiply, so it will become 5 and 2. So x5 y2 will be the atomic number or the simplest formula. Okay, very simple question to calculate the empirical formula. And listen, empirical formula there are some relations that you have to study. Okay, Ishani, correct Ishani. x2y will be the formula. Now listen here. Molecular formula is equal to empirical formula into n times. Empirical formula into n times, where n is equal to 0. That means it can be 1, 2, 3, etc. 1, 2, 3, 4, etc. Then n is equal to molecular formula mass divided by empirical formula mass. Molecular formula mass divided by empirical formula mass. And molar mass is equal to 2 into vapor density. Study these equations also, because this will be required in order to solve these kinds of questions. Okay, molecular formula is equal to empirical formula into n times. N is equal to molecular formula mass by empirical formula mass, and molar mass is equal to 2 into vapor density. Now listen. Formation. Now this question is from equilibrium. I'll give you some super tricks in this Chatellier's principle. Okay. Formation of ClF3 from Cl2 and F2 is an exothermic process. That's one the statement. Now the equilibrium of the system can be represented as. Equilibrium of the system can be represented. They have given the equation. Now listen this equation, Cl2 plus 3F2 giving ClF3. So the equation will be like this. Cl2 gas plus 3F2 gas equilibrium to ClF3 gas. And see what is the value of delta H. Delta H ku value inga paru. Delta H ku value vandu minus 329. Minus, appo 329 ku oru importance illa. Minus 329, negative, minus a. Minus means process ennadu process exothermic. Process ennada process vandu exothermic. That means forward reaction vandu endu exothermic. Forward reaction vandu exothermic. Appo reverse reaction enna idu? Reverse react. Forward exothermic aanu, reverse it will be endothermic. Forward if it is exothermic, then the process will be endothermic in reverse direction. Okay. Now listen here, effect of temperature. temperature increase ചെയ്താൽ, if temperature is increased according to Chatelier principle, temperature increase ചെയ്താൽ reaction will take place ഏത് direction? Towards endothermic direction. Whatever be the reaction, if high temperature favors endothermic direction, ഇതിൽ endothermic direction ഏത്? Backward தானே, backward. Okay, temperature decrease பண்ணியா, temperature decreased means it is exothermic, it is exothermic. So inga ippadi orthu vechuko. Now okay, temperature increased, endothermic. So you remember endothermic like this, endo. High temperature is endothermic favoring, and low temperature pare exo. Temperature kammi ayal it will be going towards exothermic direction. Okay va? But temperature, this is the answer. Okay, this will be the statement. High temperature will take place, that means that favors endothermic reaction, and low temperature will be favoring exothermic direction. This is the equilibrium chapter question. Okay. Now next concept, if you are increasing, okay, now if you are changing the pressure, high pressure, the reaction will take place from larger number of gaseous molecule to lesser number of gaseous molecule. From the side where you are having large number of gas molecule to less number of gas molecule. Low pressure means less number of gas molecule to large number of gas molecule. High pressure means like from larger number of moles to lesser number of moles, and low pressure the reaction will take place from less number of moles to large number of moles. Okay, I'll explain with this example itself. Now listen here. Which of the following will increase the quantity of ClF3 in the equilibrium? That means in order to increase the quantity of ClF3, the reaction should take place in forward direction. Forward direction means adu enna direction? Exothermic direction. Okay va? Exothermic direction means it should take place at high temperature or low temperature. That should be low temperature. There should be a decrease in temperature. First answer in the decrease, because the reaction should take place towards exothermic. See, what is the total number of gas molecules in reactant? Reactant eppadi evlo gas molecule irukku? Oru Cl and 3 fluorine. So total vandu 4. How many products are there in gas? Okay, adu vandu 2. So the reaction should take place from larger number of moles to lesser number of moles dane. The reaction should take place from larger number of moles to lesser number of moles. So high pressure or low pressure, you tell me whether the reaction, because I want the reaction to take place from larger number of moles to lesser number of moles. So what will be the apt condition in pressure? Will it be high pressure or low pressure? Can you comment it? Well, will it be at high pressure or at low pressure? Just go through that. Okay, tell me whether it will take place at high pressure or low pressure. Will it be high pressure or low pressure? Comment your answer, because we have to take. So it should be from larger number. Okay, larger number of moles. That will be an example for homogeneous equilibrium, because every gas, that means all the reactants and products are in same phase. Okay, Maheshwari, it will be in like example for homogeneous equilibrium. So large number of mole to less number of moles. Okay, larger number of mole to lesser. That means the reaction should be at high pressure. Very good, Askar. Very good, Askar. Okay. Pandiselvam, that is also correct. Okay, Shani, very good. So, okay, Maheshwari, very good. At high pressure. So, decrease, appa temperature enna pannano? Temperature must be decreased, and pressure must be increased. So, increase in pressure and decrease in temperature. So, decrease in temperature and pressure irukku. Increase in temperature, decrease in pressure. Increase in temperature and pressure. Then, see option D. Decrease in temperature, increase in pressure. Appo adu dhaan correct. Then addition of F2. See, reactant add panniya. If you are adding reactant, F2 reactant dane. If you are adding reactant, reaction will be in forward direction. If you add product again, if you are adding product, the reaction will take place in backward direction. So you have to add F2. So the answer will be option D. Okay, option D will be the answer. Is it clear? So take down those shortcuts. High temperature. Okay, high temperature will favor endothermic. Okay, so you can remember like this. Endothermic in the mari remember pannu. Endo. Exo eppadi varu? Exo. Appo low temperature exo. high pressure enna varum capital M to small n. Low pressure vandu small n to capital N. Any number of moles same irunda, if it is 3 and 3, reactant 3, product 3 vanda, there is no effect for pressure. Okay, so we'll move on to we'll see different types of questions. Okay, you can see this video. Okay, so let me explain the next question. See, when I2 dissociates to its atomic form from the following reaction. Appa I2 same type of question here, you should give me the answer. Okay, I2 gas giving equilibrium 2I gas on exothermic, so the reaction is endo, that means delta H positive. Appa reaction vandu endothermic. And see, endothermic means high temperature or low temperature. Endothermic means, so the reaction is favored at. Now you can give me the answer. The reaction will be favored at, what will be the answer, everyone? What will be the answer? The reaction will be favored at. Very good. Selvam. Okay, Party Selvam, option B, very good. So it will be favored because endothermic process on the endothermic. So, okay, Shani. So endothermic vandu enna pannano? Temperature increase pannano. So high temperature. Can you tell me in terms of pressure eppadi varu? Pressure vandu inga paru oru gas molecule have to convert that into 2. Lesser number to larger number of moles. Lesser to larger, 1 and 2 1. So high pressure or low pressure? Okay, it will be low pressure. So this will not be the answer. So the answer will be, okay, very easy. Okay, see the tricks that we are applying. Okay, now we'll move on to the next one. pH calculation. The pH of 0.001 molar barium hydroxide solution will be, remember, now listen here, pH is equal to negative logarithm to the concentration of H plus ion. pH is equal to negative logarithm to the concentration of H plus ion. And pOH is equal to negative logarithm to the concentration of OH minus ion. pOH is equal to negative logarithm to the concentration of OH minus ion. Everyone, very good. Okay, Shani, Askar, Maheshwari, everyone doing it. Okay, very good. Now listen, pH plus pOH, okay. pH plus pOH vandu adukku answer 14. Okay, that answer will be 14. Concentration of H plus into OH minus, that will be equal to 10 power minus 14. Everyone giving good support. Okay. Then if you take like K, okay, then you can also write KW. KW is equal to concentration of H plus into concentration of OH minus. Concentration of H plus into concentration of OH minus. Now, dear friends, dear students, now you need to learn some of the log value. You have to by heart log 1, log 2, log 3 up to log 10. Okay. Now listen, what is log 1? Log 1 on the 0. So you can have the values. Okay. Now listen, log 2. Okay. Log 1 will be equal to 0. Log 2, that's equal to 0.3010. Log 3 is equal to 0.4771. Log 7 equal to 0.8451. And log 10 is equal to 1. These values are enough. Values are enough to calculate almost all other log values. Okay. Suppose if you want to calculate log 4. Suppose, okay, I'll give 2-3 examples. Log 4 inga pare. Log 4 equal to log 2 square dane. And what is log 2 square? Adu vandu 2 log 2. 2 log 2. Where you know the answer of log 2. Apply. So 2 into 0.3010. If you want to calculate log 5, how will you calculate log 5? Log 5. That's equal to log 10 by 2. That is equal to log 10 minus log 2. Both the values you are having. Apply it. Okay. Then now if you want to calculate log 8, eppadi calculate pannu? Log 8 vandu log 2 cube dane. So that is equal to 3 into log 2. Log 6, how will you calculate log 6? Log 6 is equal to log 3 into 4. Okay, sorry, log 2 into 3. Adu vandu log 2 plus log 3. Log 2 plus log 3. Okay. So these are the values. You will not be able to calculate log 11, log 13, 17, 19, 23, 29, 31. Okay. For that, you just approximate. If you want to calculate 31, you go for 30. If you want to calculate 37, you calculate 36. Almost you will be getting the same. Okay, 0.01, 0.02 will be the difference. Now here, we'll go with the question. Okay, let me go with the question. So we need to calculate the pH of barium. Barium hydroxide on the strong electrolyte. So BaOH twice giving Ba2 plus 2OH minus. So 1 BaOH twice, very good, everyone already completed, yeah. So BaOH twice giving Ba2 plus 2OH minus, okay, everyone are doing it, very good, very good. Okay, Shahul Amit, Ishani, Soundarya, everyone doing it, okay. Selvam. So barium hydroxide before dissociation, barium hydroxide concentration வந்து எவ்வளோ 0.001, அது வந்து 10 raised to minus 3 இல்லையா, 10 raised to minus 3 molar. இது வந்து 0 because dissociate பண்ணதுக்கு முன்னாடி அது வந்து 10 whatever the concentration it will be there. அதுக்கப்புறம் barium hydroxide completely என்ன ஆயிட்டு கன்வெர்ட் பண்ணும், Ba2 plus and OH minus ஆயிட்டு கன்வெர்ட் பண்ணும். Okay, Ba2 plus and OH, we have only just half 30 more minutes, okay. So அதுக்கப்புறம் இங்க வந்து 0 molar. That means after dissociation BaOH twice வந்து 0 molar. Ba2 plus எவ்வளோ ஆகும், 10 raised to minus 3. அது வந்து ஒரு Ba2 plus, okay, ஒரு Ba will give you 1 Ba2 plus. OH minus எவ்வளோ வரும், 2 into 10 raised to minus 3. So what is the concentration of OH minus? Concentration of OH minus is equal to 2 into 10 raised to minus 3. 2 into 10 raised to minus 3. And what will be the concentration of H plus? We know that concentration of H plus into OH minus வந்து 10 raised to minus 4. That is equal to 10 raised to minus 14 divided by concentration of OH minus, which is equal to 10 raised to minus 14 divided by 2 into 10 raised to minus 3. Ready? So that will be equal to, so 1 by 2, okay, 1 by 2 on the 0.5. 0.5 into 10 raised to minus 11. 0.5 into 10 raised to minus 11, or that's equal to 5 into 10 raised to minus 12. 5 into 10 raised to, so concentration of H plus is 5 into 10 power minus 12. Now listen, what is pH now? pH is equal to negative logarithm to the concentration of H plus, negative logarithm to the concentration of H plus, that is equal to negative logarithm of 5 into 10 power minus 12. So that is equal to minus log 5 plus log 10 raised to minus 12. So what is log 5? Log 5 is equal to log 10 by 2, and solving you'll get answer as 0.7. Log 10 raised to minus 12 on the minus 12. Okay, log 10 raised to x is equal to x. But 10 raised to minus 12 will be minus 12. So that is equal to 12 minus 0.7. 12 minus 0.7, which is equal to 11.3. 11.3 will be the pH value. 11.3. Okay. It's a very simple question. Okay, 11.3. 11.3 will be the right answer. And also you know that barium hydroxide on the base. Barium hydroxide base இந்த இதில் ஏதற்கு answer வராது, 2 வராது, 2.7 வராது. Okay, so these are the two possible, because the basic pH you have to take. Okay, you have to take the basic pH. Okay, very good, very good. We'll move on to the next one. What will be the pH of 10 raised to minus 4 molar H2SO4, 10 raised to minus 4 molar sulfuric acid? Listen here, first of all I can assure you that இது வந்து answer வராது. 10.4 basic pH, 13 வராது. So the answer can be either 3.7 or 3. Answer will be either 3.7 or 3, because we are dealing with acid, and acidic pH வந்து 0 to 7. Acidic pH will be between 0 to 7. Now listen here, sulfuric acid H2SO4. H2SO4 வந்து 2, okay, 2H plus and 1 SO4 2 minus, 2H plus and 1 SO4 2 minus. Now here we know that 10 raised to minus 4, okay, இது வந்து 10 raised to minus 4 molar, இது 0. Before dissociation. After dissociation 0 molar. Okay, now we'll be getting 2 into 10 raised to minus 4 vandu. H plus will be 2 into Shahul Amit, 2 into 10 raised to minus 4. SO4 2 minus and the value will be 10 raised to minus 4. Okay, 10 raised to minus 4. Now we can see that pH எவ்வளோ வரும்? pH is equal to negative logarithm to the concentration of H plus. Negative logarithm, everyone giving good answer. Okay, very good, yes. So minus log 2 into 10 raised to minus 4. This solve பண்ணி you'll get the answer. So what is that? That value will be minus of log, okay, minus of log 2 plus log 10 raised to minus 4. So what is log 2? Log 2 will be 0.3010. You can take 0.3 minus 4. So 4 minus 0.3, that's equal to 3.7. 3.7 will be the right answer. Ready? Then Next one, okay, you can do it. What will be the pH of a sample of soft drink if the hydrogen ion concentration in the sample is 3.8? So you do one thing, 3.8 and you approximate, okay, you approximate that into 4. Same type of question. So you can, it's an NCERT exercise itself, okay, 3.8 into 10 raised to minus 3, and approximately you can do it as 4 into 10 raised to minus 3. Approximately you can do it as 4 into 10 power minus 3. Okay, wow. You can do it, so I'm not going for that question. Then, next one, what will be the solubility of AgCl in 0.05 molar NaCl aqueous solution if solubility product of AgCl is 1.5 into 10 raised to minus 10? And that's in the theory part. Okay, now the theory part. Solubility product of MX4. Now MX4 type, if you have a salt of the type AXBY, if you have a salt of the type AXBY, then KSP value, we have the equation KSP is equal to x raised to x into y raised to y into s raised to x plus y. X raised to x into y raised to y. Shahul Amit, that answer maybe 2 point, we have to check that one, okay. X raised to x into y raised to y into s raised to x plus y. Others, are you getting the answer of pH 2.42? That's the sample of soft drink, okay, you try it. Now, if it is like MX4, okay, now MX4 bare, MX4 la vandu, see, M1X4 on, M1X4. So what will be the value of KSP? KSP will be 1 raised to 1 into 4 raised to 4 into S raised to 1 plus 4 vandu. So that is equal to S raised to 5, and this answer will be 256, okay, this will be 256. 256 s raised to 5. 256 s raised to 5. Okay. Now we'll take the previous question. See, this was also one of the previous year question. Okay. What will be the, so in 2020 or 2021? What will be the solubility product of AgCl in 0.05 molar NaCl? Now you are dissolving. Okay. We are dissolving it in 0.05. Okay. 0.05 molar NaCl. 0.05 molar NaCl. 2.42 will be the correct. I think that we have to check that one. Okay. Anyhow, we'll complete this question first. So here, after adding, which is the, okay, we are adding AgCl. So you know that AgCl is a sparingly soluble salt. AgCl is a sparingly soluble salt. So here, degree of dissociation and the trick illa, okay. So AgCl will be giving Ag plus and Cl minus. So here KSP value, appo answer vandu ipo paru, KSP value, KSP is equal to concentration of Ag plus into concentration of Cl minus. For the above equation, on the basis of the above equation, concentration of Ag plus into concentration of Cl minus. Okay, wow. Now here concentration of Ag plus vandu, you can give it as S. Okay, here if it is giving it as S. Now idu vandu S, Ag plus. Appa S Cl minus concentration vandu S. If it is 2Cl minus, you have to take it as 2S. Now listen, also you are having NaCl irukku. We are also having NaCl. NaCl eppadi dissociate aidu? NaCl vandu Na plus Cl minus thane. அப்போ NaCl concentration வந்து 0.05 molar. So Na plus will be 0.05 and Cl minus will be 0.05. So what is the concentration of Ag plus? Concentration of Ag plus வந்து S. Ag plus concentration வந்து S. And what will be the concentration of Cl minus? அது Cl minus இங்கே வந்து S இருக்கும், NaCl 0.05 இருக்கும். அப்போ total எவ்வளவு வரும்? S plus 0.05 வந்துடும். S plus 0.05. And remember S value, solubility value, solubility normally having too small. Okay, solubility will be very small. Very small. For sparingly soluble salt. Appo S plus 0.05 is approximately, you can take it as 0.05. Okay, we are going with a mild approximation there. So what is KSP? KSP is equal to concentration of Ag plus, that's S, into S plus 0.05. Now what is KSP value? KSP value வந்து 1.5 into 10 raised to minus 10. 1.5 into 10 raised to minus 10, that is equal to S into 0.05, because this will be approximated to 0.05. So what is S? S will be equal to 1.5 into 10 raised to minus 10 divided by 0.05. This is the calculation. 1.5 into 10 raised to minus 10 divided by 0.05. Your option will be option A will be the right answer. Okay. Option A. Is it clear? So here we have to test. So normally if it is not given, okay, but 0.05 NaCl, if it is not given, then you can take it as Ag plus, that means KSP is equal to S into S. In the S mattum podu. If it is given like in some other solute or some other solvent, then you have to consider that value also. Total value must be considered. Okay, 0.05 vandu. Ready? Then what will be the molarity? What will be the molarity of 30 ml 0.5 molar sulfuric acid? Now you are having 30 ml of 0.5 molar sulfuric acid diluted to 500 ml. இப்போ முதல்ல எவ்வளோ இருக்கும்? முதல்ல யூ ஆர் ஹேவிங் 30 ml, இங்கே 30 ml இருக்கும், 30 ml. அதுக்கு கான்சன்ட்ரேஷன், வாட் இஸ் த கான்சன்ட்ரேஷன்? 1 minute. Please wait, okay. So we'll go to that slide. Okay. So we are having 30 ml. We are having 30 ml. Sulfuric acid, அதுக்கு concentration வந்து 0.5 molar, and it is diluted to how much? 500 ml. அதுக்குள்ள molarity M2 அது calculate பண்ணணும். That means molarity before into volume before is equal to molarity after into volume. Dilution lo nu sollu. M1 V1 simple equation, M1 V1 is equal to M2 V2. Now what is M1? M1 வந்து 0.5 into V1 30. That is equal to M2 into 500. M2 into 500. அப்ப M2 எவ்வளவு வரும்? M2 is equal to 0.5 into 30 divided by 500 வரும். 0.5 into 30 divided by 500. And normally that value will be less. Okay, always that means on dilution. On dilution, your value will be decreased. Okay, so remember this equation. M1 V1 is equal to M2 V2. M1 V1 is equal to M2 V2. Now the molality of 648 gram of pure water. It's a very simple question. I just want to give you a calculation. That's all. Okay, now you have to see, you know that molality is equal to weight like WB divided by MB into 1000 divided by WA. WB divided by MB into 1000 divided by WA. So here water we are taking pure water. So in pure water, like you are calculating the molality, so you can take it as like the same. Okay, so here if I am taking whatever be the water, that means molality, if you take that will be, you can do it as like if you go with the calculation, it will be like 1000 by 18. 1000 by, okay, it should be molarity. Okay, wait, molarity. So molarity will be equal to capital M. Molarity will be equal to WB divided by MB into 1000 divided by V. Volume must be given in milliliter. And you know that 1 ml water is equal to 1 gram always. 1 ml is equal to 1 gram. So volume in ml will be equal to weight in grams. 500 ml, that means 500 gram. 600 ml, 600 gram. 648 gram means 648 ml. So this will be cancelled. So that is equal to 1000 divided by MB. So what is the molecular mass of water? Molecular mass of water will be, okay, we'll get 1000 divided by 18 eduthuko. 1000 by 18. And that value will be 55.55. By heart this value. 1000 by 18. That will be equal to 55.54. That means naraya calculation. Chemistry in most of the calculations we are having this value 1000 by 18. Okay, there will be repeated calculations. So by heart the value that is equal to 55.55. Okay, we are calculating the molarity. Okay, not the molality. I calculated the molarity. Now listen. Next we'll move on to See, a first order reaction, that's question from chemical kinetics, okay. A first order reaction takes 40 minutes for 30% decomposition. The first order reaction takes 40 minutes for 30% decomposition. What will be the T half value? So first order reaction thane, first order reaction. First order reaction, what is T half? T half is equal to 0.693 divided by K. T half is equal to 0.693 divided by K. So we have got, okay, K is equal to 2.303 divided by T log R0 divided by R. 2.303 divided by T log R0 by R. See here, the time is given in minutes, and also the answer is also given in minute. Okay, always check whether it is, sometime it will be in seconds in question and minutes in the answer. The time, the unit must be same. So a first order reaction takes 40 minutes for 30% decomposition. If 30% is decomposed means 70% will be remaining. Here R indicates the amount of substance present at time t. But 30% dissociate pannadukku appro you will be having 70%. Okay. So the value of R is equal to R0 ku 70% will be remaining. You can write like this. Okay, wow. So K is equal to, so which color? Is this color fine? Yellow? Hope it is fine. Okay, so I will not be using the red again. Okay, ready. So K is equal to 2.303 divided by T. T will be now 40 minutes. Okay, 40 into log R0, okay, R0 divided, now what is R? R0 into 70 by 100. So R0 cancelled, 100 by 70 out, that is 10 by 7. Now K is equal to 2.303 divided by 40 log 10 divided by 7. So what is log 10 by 7? Log 10 by 7, log 10 by 7 is equal to log 10 minus log 7. So what is log 10? 1. Log 7, 0.8451. You take it as 0.85. That's equal to 0.15. Okay, wow. Now listen here. If I take this one, so K is equal to, so I got K is equal to, that's equal to 2.303 divided by 40 into 0.15. Now we have to calculate T half. When T half another 0.693 divided by K, so I'll apply the value. So here T half is equal to, now listen here, T half calculation. T half is equal to 0.693 divided by the value of K. Substitute the value. 2.303 into 0.15 divided by 40, and it will become into 40. And remember 0.693 is actually, okay, I'll give you one more trick in the calculation. 0.693 means 2.303 into 0.3. 2.303 into 0.3, that will be equal to 0.693. So, this divide பண்ணதுக்கு 0.3 வந்துடும் 0.3 divided 0.5, okay, 2. So your answer will be approximately, like 2 into 40. That means we are approximating, okay, you will be getting an answer of 77.7. So here the value of T half, that will be 0.693 divided by, okay, you can apply the value, and approximately this will be the answer, 77.7. Okay, remember 2.303 into 0.301. 2.303 into 0.301, that will be equal to 0.693. Okay. So you have to apply the log values also. Okay. Next one. And remember, your answer will be greater than 40. Okay, always your answer will be, because 30% decompose pannadukku, 30% decompose pannadukku, it takes 40 minutes. But 50% decompose pannadukku, your answer will be greater than 40. Okay. Then next one, we'll move on to some question from okay. The magnitude of magnetic moment NiCl4 2 minus. The magnitude of magnetic moment Cl4 NiCl4 2 minus. So I think this will be the last question that we'll be discussing. Okay, NiCl4 2 minus. So magnetic moment calculate pannadhukku we have a formula. Now what is the formula? Mu is equal to root of n into n plus 2. Root of n into n plus 2. Appadi alle avlom Bohr magneton. Where n is the number of unpaired electrons. அப்போ NiCl4 2 minus முதல்ல என்ன கால்குலேட் பண்ணு, நிக்கலுக்கு ஆக்சிடேஷன் நம்பர் கால்குலேட் பண்ணு. ஓகே, வில் கால்குலேட் ஆல்சோ. இட் வில் பி x minus 4 equal to minus 2 இல்லையா? x chloride வந்து நெகட்டிவ் 1 minus 1 for 1 chloride. So x is equal to plus 2. x is equal to plus 2. Now listen, இது வந்து Ni2 plus தானே, Ni2 plus. நிக்கலுக்கு ஆக்சிடேஷன் நம்பர் plus 2, so it will be Ni2 plus. அப்போ Ni2 plus வரும்போது Ni2 plus will be having, Ni2 plus means it will be like a nickel 3d8. Okay, nickel will be 3d8 4s2. Nickel will be 3d8 4s2. அப்போ Ni2 plus will be 3d8 4s0. Ni2 plus will be 3. அப்போ இங்க பாரு Ni2 plus 3d8 தானே, 1 2 3 4 5 6 7 8 3d8. How many unpaired electrons are there? How many unpaired electrons? 2 unpaired electron irukku. Now 4s, s orbital, p orbital. So 3d 4s 4p. So secondary valency 4. Secondary valency 4 hybridization can be either sp3 or dsp2. Hybridization may be either sp3 or it can be dsp2. Coordination number 4 vanda. Okay, if coordination number, listen carefully, coordination number if it is 4, then hybridization will be either sp3 or dsp2. So these two electrons, will it pair? That pairing will take place only under the influence of strong field ligand. The pairing will take place only under influence of strong field ligand. What about Cl minus? Cl minus வந்து weak ligand. Weak ligand pairing will not take place. As a result, what will be the hybridization? This molecule, இந்த molecule hybridization வந்து see, unpaired empty orbital தான் hybridize பண்ணும். So ஒரு 4s and 3 4p. So hybridization என்ன வரும்? sp3 வந்துடும். So that is not our concern in this one. So what is the number of unpaired electron? Number of unpaired electron 2. So what will be the formula? Mu is equal to root of 2 into 2 plus 2. So root of 2 into root plus means root 8. Root 9 1 to 3. But root 8 will be less than 3. Less than 3 means 2.82 will be the right answer. 2.82. And remember here also I'll give you some values. Okay. Now listen. Number of unpaired electron 1 agalam. It can be 2, it can be 3, it can be 4 or it can be 5. അങ്ങനെയാണ് ഇതാ the magnetic moment mu. ഇങ്ങ വന്ന് root 3 വന്നിടും. Okay. Root 1 into 1 plus 2. That will be root 3. 2 unpaired electron means root 8. 3 unpaired electron means root 15. Here it will be root 25 and here it will be root 35. Sorry, 24. Okay, not 25, it will be 24. 4 into 6 and root 35. And the value will be 1.73 and you remember it as 1.8. Root 8, 2 unpaired electron in the 2.8. 3 unpaired electron in the 3.8. 4 unpaired electron in the, so what will be the value? So what will be the magnetic moment if you have 4 unpaired electron? 4 unpaired electron in the, it will be 4.8. 5 unpaired electron in the 5.8. Approximated answer. All these are approximate. This is enough for NEET. This is enough. Approximately. So if you have the magnetic moment as 3.8 Bohr magneton, if you are getting the question, then here you will be having 3 will be the number of unpaired electron. So spectrochemical series therinjukkodum. Okay, then only you will be able to identify whether it is a strong field ligand or a weak field ligand. Okay, now listen. Spectrochemical series munnadi I'll tell you a small story. Okay va. இப்போ உங்களுக்கு தெரியும், இப்போ ஐகானிக் பாரதியன் இல்லையா? இப்போ ஐகானிக் பாரதியன் வந்து யாரு? அது வந்து சச்சின் டெண்டுல்கர் இல்லையா? ஐகானிக் பாரதியன். அப்போ ஐகானிக் பாரதியனை சச்சின் டெண்டுல்கருக்கு க்ளோஸ் ஃப்ரெண்ட் இருந்து. ஓகே, இஸ் ஹேவிங் ஏ க்ளோஸ் ஃப்ரெண்ட். அந்த க்ளோஸ் ஃப்ரெண்டு வந்து ஒரு கெமிஸ்ட். ஓகேவா? அண்ட் ஹி வாஸ் டூயிங் சம் எக்ஸ்பெரிமெண்ட். ആ ക്ലോസ് ഫ്രണ്ട് ഹൈഡ്രോക്സൈഡും ഓക്സൈഡും കൂടെ ചേർത്ത്. ഓക്കെ, ഹി ടുക്ക് ഹൈഡ്രോക്സൈഡ് ആൻഡ് ഓക്സൈഡ്, அதுக்கு தண்ணி ப்ரிப்பேர் பண்ணு. இப்போ தண்ணி ப்ரிப்பேர் பண்ணி, அப்போ ஆக்சுவலி ஹைட்ரோக்சைடும் இல்லை ஆக்சைடு, தட் மீன்ஸ் ஆக்சுவலி இட் ஷுட் பி H+ and OH-. அப்போ தட் ரியாக்ஷன் வாஸ் தப்பு. அண்ட் தென் நீரஜ் சோப்ரா உங்களுக்கு தெரியும். யாரா நீரஜ் சோப்ரா? நீரஜ் சோப்ரா வந்து ஜாவலிங் த்ரோ எக்ஸ்பர்ட் இல்லையா? இப்போ நீரஜ் சோப்ரா வந்து ரொம்ப டயர்டு, இப்போ இந்த மாதிரி ப்ராக்டிஸ் எல்லாமே பண்ணி ரொம்ப டயர்டாகி வந்து அந்த தண்ணி எடுத்து அதுக்கு இன் ஆர்டர் டு ட்ரிங்க். அப்போ அது வந்து ஒரு தெட்டில் ஒரு ராங் எக்ஸ்பெரிமெண்ட் ஆக்சுவலி இட் இஸ் நாட் வாட்டர். அப்போ அந்த தண்ணி எடுத்து, அப்போ அவருக்கு ஒரு ஃப்ரெண்ட் இருந்து அமீன். அப்போ அமீன் வந்து சொல்லி நோ அது வந்து சயனைடு காம்பவுண்ட்னு சொல்லி, ஓகே அது வந்து ஒரு சயனைடு காம்பவுண்ட். அப்போ ஸ்டோரி இந்த மாதிரி, ஐகானிக் பாரதியன் சச்சின், ஓகே ஐகானிக் பாரதியன் சச்சினுக்கு க்ளோஸ் ஃப்ரெண்டு என்ன பண்ணி ஹைட்ராக்சைடு ஆக்சைடும் சேர்ந்து தண்ணி ப்ரிப்பேர் பண்ணி, அப்போ நீரஜ் சோப்ரா வந்து அதை எடுத்த சமயத்து யார் வந்து அமீன் வந்து என்ன சொல்லி நோ அது வந்து என்ன சயனைடு காம்பவுண்ட்னு சொல்லி. Now we'll see that, okay, now we'll go to our spectrochemical series, okay, spectrochemical series. So we'll recall that story that I have done, okay. So iconic Bharatiyan, so Br minus, okay. So iconic Bharatiyan யாரு சச்சின், SCN minus. iconic Bharatiyan சச்சினுக்கு யாரு க்ளோஸ் ஃப்ரெண்டு தானே, க்ளோஸ் ஃப்ரெண்டு. அப்போ ஐகானிக் பாரதியன் சச்சினுக்கு க்ளோஸ் Cl மைனஸ் S2 மைனஸ் F மைனஸ். க்ளோஸ் ஃப்ரெண்டு என்ன பண்ணி, க்ளோஸ் ஃப்ரெண்டு ஹைட்ராக்சைடும் ஆக்சைடு, ஓகே ஹைட்ராக்சைடு அண்ட் ஆக்சைடு சேர்த்து என்ன ப்ரிப்பேர் பண்ணி தண்ணி ப்ரிப்பேர் பண்ணி. அப்போ அங்கேக்கு யாரு வந்து அங்கேக்கு நீரஜ் சோப்ரா இல்லையா, NCS மைனஸ். நீரஜ் சோப்ரா வந்து தண்ணி எடுத்து, ஓகே எடுத்து EDTA 4 மைனஸ். அப்போ அது வந்து தண்ணி அல்ல, அது வந்து ஒரு ராங் எக்ஸ்பெரிமெண்ட் தான், ஓகேவா. அப்போ அந்த தண்ணி எடுத்த சமயம் அங்கே யாரு வந்து இல்லையா, அப்போ EDT, அப்போ நீரஜ் சோப்ராக்கு ஃப்ரெண்டு பேரு என்னது அமீன், ஓகே அமீன் அமோனியா இல்லை NH3EN ரெண்டு கூட சேர்த்து அமீன் வாய்ச்சு. அமீன் வந்து என்ன சொல்லி நோ, ஓகே ஒரு நோ அல்ல நோ, அப்போ NO2 நோ அது வந்து என்னது, அது வந்து சயனைடு காம்பவுண்ட். இதுதான் ஸ்பெக்ட்ரோகெமிக்கல் சீரிஸ். எப்படி வரும், ஓகே I minus, now listen, I minus less than Br minus SCN minus Cl minus, okay. So it's the super trick to remember. This is the super trick to remember the spectrochemical series. So we'll end this session with this trick, okay. SCN minus, Cl minus, S2 minus, F minus, OH minus, H2O, NCS, okay, EDTA, NH3, ethylene diamine, Cn minus and CO. Just go through that sequence, okay. Is it clear? ஐகானிக் பாரதியன் சச்சினுக்கு க்ளோஸ் ஃப்ரெண்டு ஹைட்ராக்சைடு ஆக்சைடும் சேர்த்து தண்ணி ப்ரிப்பேர் பண்ணி நீரஜ் சோப்ரா வந்து எடுத்து, ஓகே எடுத்து. அப்போ அமீன் வந்து என்ன சொல்லி நோ, ஓகே NO அல்ல நோ ஆன், ஓகே யூ ஹேவ் டு எக்ஸ்டெண்ட் இட் NO2 நோ அது வந்து சயனைடு காம்பவுண்ட். It's very easy to remember, okay. இதுல வந்து இங்க பாரு NH3 onwards, okay NH3 onwards you can take it as strong field ligand. NH3 onwards you can consider it as strong field ligand and all other cases will be weak field. But idhula nariya exceptions irukku, okay, because sometime like H2O will be acting in both strong field and weak field ligand I behave pannu. NH3 in some cases is strong field, and so we have to study the exceptions. Everything must be discussed, which I have not discussed in this section, okay. So spectrochemical series this is the shortcut that we'll be using. அப்போ இதில் வந்து இது increasing order. So this is the increasing order of energy and this is the increasing order of their energy. Increasing order of energy and it will be decreasing order of wavelength. Okay, this will be the decreasing order of their wavelength. So which is having highest energy யாருக்கு carbonyl. Highest wavelength யாருக்கு வரும் I minus. Okay, because energy and wavelength will be inversely related. High energy means low wavelength. Okay va? Is it clear for everyone? So in this section we were discussing like the topics from, I took some of the questions from physical chemistry and mainly where we can apply the shortcuts, okay. So don't think that this is only question that will be coming from physical chemistry. We have taken only those questions where we can apply the shortcuts in their calculations, okay. And in spectrochemical series also we have seen some of the shortcuts, okay. Clear for everyone? And I have given like one question, okay, one section like that soft drink pH. You just find the answer and see how to calculate the pH values also. So everyone was like successfully everyone was participating, okay. Maheshwari, Ishani, then Venkatesh, then okay. Soundarya Murugan. Hope it is clear for everyone. So shall we wind up? Okay. So all the best for you everyone for your NEET examination, and study well, prepare well, and never do any careless, okay, careful, that means should be very careful while attending the questions, and don't do any careless mistakes. Okay, read the question properly, like from physical chemistry and all, read the question carefully. There will be some hidden tricks will be there in the question, okay, some twisted questions will be there. So read it carefully and identify the concept, then apply the formula. Okay, so this is how you have to, that means, and also make your calculations part very fast. Okay, so anyhow, let me wind up. So everyone, once again, all the best for everyone. Thank you all.